Hi, everyone. Welcome back to the Postman webinar. Today we'll be covering tests and scripts. This is a presentation given by one of our product engineers, Numan. We'll just be walking through various ways of achieving some functionality before and after you run a response, as well as verifying that the response looks a certain way or does what you want it to do. As always, I would encourage you to take a look at the Postman webinar page that we'll post up in the chat, just to keep track of what's going on and what'll be coming up in the future, and as well as post any questions you may have in the Zoom chat while we're going on. So without further ado, we'll jump right into it. So first today we're going to talk about API testing, and I am curious just go ahead and give a little shout out in the Zoom chat if you've written a test for one of your APIs before, or one of the requests that you've made in Postman. Awesome. Seems like some of you have. So I've just realized that we aren't screen sharing right now, so I'll go ahead and do that for you. Awesome. So it's good to see that some of you have written API tests. And I'm curious, how many of you actually have a primary function of writing these tests? Is this something that you do on a daily basis? And is this something that you've interacted with before? It's good for us to get an idea of whether or not this is something you're learning, or whether or not this is something you're just checking back in to refresh your knowledge. Okay, cool. So I'm seeing that some people do, okay. So some people are learning and some people are doing this primarily for their jobs. So that's great to hear. And no matter what stage you're at in your Postman knowledge, please jump in and ask questions as we move through, because there's a lot to clarify and move through for tests and scripts. So why test APIs? In general, it's important to test APIs just because oftentimes there are automatic things going on that interface with the application logic. We need to be able to automatically confirm that these things are performing correctly. And oftentimes this takes the form of a contract. An API, from its endpoint to the place that's sending a response, has an expected behavior. So either we're going to send a certain error, certain response code, things should happen in a certain period of time, and the response should be formed in a certain way. This expectation from both sides as to what's sent to the API and what's sent back is what we would call a contract. And one of the important parts of testing is to identify these failures early on. In fact, many people will tell you that it's important to fail fast. So one of the best things about Postman is it allows you to really get in, interact with your API, and identify these failures with testing early on. So the things that we test for in Postman, as well as in automated tests, is functionality, performance, reliability, and scaling. The functionality is what I was just talking about in terms of whether or not things are basically performing in the way that we want them to perform. Are we getting the right responses? Is everything functioning correctly in such a way that we can confirm that the API is doing what we want it to do? Next, we're thinking about performance. So how fast is the API returning things to us? Is the API processing things in a reliable manner? Is this something that we can expect to function quickly and work as part of maybe an enterprise integration, or an application that is across multiple platforms? Next, we're looking at reliability. So reliability is what happens across, say you have an API that has thousands of calls a second. Oftentimes you have to worry about some site engineering problems, like what if your server goes down? What if your API puts too much load on some part of your infrastructure and starts responding a lot more slowly? That is what we think about when we think about reliability, whether or not we can hit an API at different times of the day in different regions. and still expect it to act the same way. And finally, we want to test for security as well. So making sure that authentication is functioning correctly, not just anyone can access our private API, or you're not able to do things like use an SQL injection to access information you shouldn't be able to access, or get functionality that is normally restricted. So these are all sort of 4 important pillars of API testing, and things that are important to keep in mind when you do sit down to write tests and interact with APIs in Postman. So with Postman specifically, testing takes the form of JavaScript code that's executed after the response for a request. We have the ability with the Postman Sandbox API to interact with the request, response, and all of the different variables we have in our environments, which we saw last time, as well as our parameters and anything that might be floating around on the global collection or folder level. In addition, there is also an area within the app itself in the GUI that has a test results tab. We'll be looking at that in a little bit, but you can see it here. It's actually highlighted there in the image for test results. So now we're gonna hop into the Postman app and show you a little bit of what we can do with tests and scripts. So the first thing we wanna look at is Twitter search. So we're just going to make a quick call. We have everything loaded up in an environment here. That just is going to allow us to, that's just going to allow us to see some stuff. So what we're searching here is PostCon 2018. This is just, a simple way to, through Twitter, search basically the top 10 tweets that have recently mentioned PostCon. Here we're not seeing anything that actually says PostCon, which is funny enough. I saw something just last time. Instead, let's just look for something that's mentioned PostCon. So here we see that it's returning a pretty complex object that has a lot of information about a lot of different tweets. So obviously, this is something that if we're doing it by hand, it would take a lot of effort to parse, to really understand. So there's some things that we can do to abstract out this work and make our jobs easier as API testers. The first thing I want to show you is basically the set of tests and how we test within Postman. The PM extension in JavaScript is part of the Postman Sandbox API, which we discussed earlier. So when you say pm.test, this is actually the format that tests in Postman take. What you do is you'll say the name of the test as well as so that's basically the response, and then you'll give a function. So what this function is it actually tells your test what to expect. And the pm.expect function is how we do this. So here, what is going on in the anatomy of this test is we are telling the Postman API to expect from the response a status code that equals 200. So this is using the try.js syntax, which is pretty readable, but just so you understand, the response object here that we're putting in is actually the response that is being returned by the actual API. So when we, in this search, see the response body that's returned here, this is all codified and actually accessible in the sandbox through the Postman API. When we say code here, we're also we're accessing the status code. And then within our testing expectations, basically the Postman Sandbox API, we're saying to equal. Basically, we want to know that the status code is 200. So let's go ahead and send our test, or send our request and see what happens. So here we are. We've gotten our request. Like we saw before, 2018 isn't returning anything, but we do have a status code of 200. And we see a pass here in the test results tab. If we were to copy this and look for a different status code, we would start to see failures. So let's try this. Okay, now we see that we do have, there's an assertion error. We expected 200 to equal 201. So we do have the status code of 200, but we have not received 201, which is what we are looking for. You are able within this test results tab to skip forward and look at anything that maybe is passed, skipped, or failed. So we won't be covering passed and skipped here because those are edge cases, but for all and failed, oftentimes what you're going to be looking at is failed. Those can be handy when you're running a lot of tests. So let's look more not just at the response, but the response body. So we saw an example of what the PostCon 2018 request looked like. Here, we are not just searching for the status code equal 200, we actually have done something else where we're looking for PostCon 2018. Here, we see the same pm.expect function, but we also see pm.response.text. So now we're searching through the actual text of the response and looking for it to include PostCon 2018. So rather than looking for it to equal, this actually scans the body of the response text to look for this specific string. Let's see if we find anything. We should expect this test to fail because we weren't able to find any. So we do see a response has PostCon 2018. Let's see what went on there. Here we go. The query contains PostCon 2018, so it did in fact return positive. Let's see if we turn this into 2017. Once again, we see that this fails. So basically, this will return information that gives you just a little bit more visibility into what's actually going on inside of your tests. Are there any questions thus far on what we've covered in tests and scripts? Awesome, I'm seeing that we have some questions. Could we just let me know what you're thinking? So no, the question that was asked is whether or not we need to use Postman or pm.response.json, which we'll be getting to in just a little bit, to parse the response. In this case, we do not. The response.text just views the entire response as a string and looks for substrings that have basically the string that you're giving in the include function. So, awesome. Is there anything else? So in terms of whether or not the test input is static, if you could clarify that question a little bit. If you're asking the specific, this PostCon 2018 or 2017, that is a static thing that we're putting into it. However, we could, as we saw in the last webinar on variables, access something from our actual environment and see if we can use it. So we could actually say pm.environment.get, and then we could say data. So now we have now we're directly pulling one of our variables from the environment. Let's look at our test results. So we did not see that our test included 1, 2, 3. But if we were to change this and maybe add a PostCon variable, and let's say PostCon 2018 update. So now we can look for PostCon variable, and we can see that it does in fact have PostCon 2018. Awesome. So, and we will actually get to a little bit later in this webinar, the ability to not just set these, not just inject non-static things into your tests, but look at how we can chain things to actually build on top of what we have with environments and get some more complex functionality. So there are a lot more ways to test within Postman. And here we see a few different varieties. We can look at the different status codes, we saw already. We can look at whether or not they include text. We're also able to scan headers. Here we can see a syntax that we haven't explored yet, which is it's actually a little more powerful within the Sandbox API. So rather than saying pm.expect, we can actually use a shorthand that says pm.response.toHave, and then we can use a different, basically we can use a modifier to say what we're expecting. So in this case, we're looking for a header that includes content type. So let's go ahead and send our request and see what came back. So looks like, as we saw earlier, we actually aren't getting anything back with PostCon 2018, so this has failed. Just look at this real quick. Huh, that's strange. This is maybe something that we could look into a little bit later. However, the content type is present in the headers. If we look at these headers, any of these we can search for. We can also see date. So let's change this to date. We can see, oh, sorry, we need to save this real quick. Huh, that is strange. Well, interesting. Oh, sorry, that's what's going on. And this is a good example of why it's important to keep track of the entire anatomy of your test when you write it. So even though I've changed the expectation of the test, I didn't happen to change the title. So now I can say date is present, and it should modify. So now we can see date is present. However, if we potentially miswrote, said that, so now we aren't able to find a header with the key data. As you can see, we always get an interesting amount of information that's returned for when these are failed. There is, however, ways to look a little bit deeper into what's going on. So we can use the Postman console that we saw a little bit earlier in the webinar series and actually see what's happening when we run our responses. So let's go get that console back. Oops. And we'll send. So here we can see that things, and we can actually see the collection test script has run. Currently, we're not getting any information on this, but in a little bit, we'll be covering scripts and we'll see how we can actually get more input to the console. So, sorry, we're getting a question in the chat that's asking about the benefit of using pm.response.code versus responsecode.code. So it seems that one of our users was having shortcomings with the PM method. So basically, there isn't a benefit to or for or against using either responsecode.code or pmresponsecode.code. There are at times limitations to the to the Postman sandbox, in that not every, this is a limited set of functionality that we have built out for you to use, and I'll actually point you at the end of this webinar to a set of documentation. But these are just two different ways to say the same thing. The response to have can at times be limited in terms of being able to access your response directly and expect things from it. So I wouldn't say that there are strong positives or negatives to either one, since they oftentimes end up being essentially the same thing. The only slight difference is that responsecode.code might give, and it doesn't always have to be .code. The responsecode.something or response.something might give you a little bit more accessibility into the information that's there, especially if we are expecting some strange data type that isn't part of what's automatically built into the Postman sandbox. So moving on, we can also not only test headers, we can also test pretty much anything that shows up in this little corner down here. So here we're looking for response time, and we're seeing that it is less than 1,000 milliseconds. This is good for testing the performance, which we were talking about earlier. All of these things are sort of, basically this goes into the contract that we were talking about. expecting that there is a date present is part of the contract that we have with our API in order to know the headers that we'll be getting back and the information and form of the data that will be being returned. Knowing that our status code is 200 lets us know that our API is functional, it's performant, that we are actually able to access what we're trying to access and that we've done it correctly. So that confirms that our request is not malformed and that our response looks good. In terms of the testing, this goes into the idea of performance again. It lets us confirm that the information that we're accessing is actually there and gives us a little bit of functional testing in terms of whether or not basically the operation we're trying to perform is valid. So let's move on to a little bit more complex test. The Postman API has not just the PM function, but also a few other extensions that allow us to do some more complex things with the sandbox. So here we're going to do something called defining a schema. When we've looked at our response before, we can see that there is this search metadata that's popping up at the end of every request or every response that we're getting from the Twitter API. And we know that this is something that we're always going to expect. So this is a good way to really build out your contract. What we're looking for is an object that has these properties. We wanted to know that it has completed in, which is a number, max ID, which is an integer, max ID string, which is a string, the next results string, query, refresh URL, count, since ID, and since ID string. You can see that this allows us to not only define an expected key value for the return type, but also an expected type. This is helpful because it allows us to always expect the same form of a response. An example of why this might be necessary is if two teams are working independently and one of them happens to change their API, if you're always testing for a schema, you can detect that change instantly, especially if it's a change that will affect the other team's workflow, such as breaking something or causing a different outcome. So here, the other thing that we're doing is we are testing that the metadata schema that we've just defined here, and we've set we've set this entire schema as a JSON object equal to this variable. So we're gonna make sure that this is valid. This is just like any other test, it just is a little more complex. So we're using let here, and what let does is it actually is basically a programming construct that allows us to do something similar to expect. So we're saying that the JSON data is actually now equal to the pm.response.json. We had a question earlier about JSON. What JSON does is this allows us to turn the response into a consumable JSON format, like we see here. Before, when we've been processing it, our API or our sandbox has actually been looking at it like this, which is why we didn't need to turn it into JSON when we used postman.include. Now that we're looking at it as JSON, we can actually compare it to our schema. This validation is using a library that we call TV4. TV4 is something that's available automatically within Postman. So it has a function called validate where we can compare two different JSON objects. So the JSON data.search metadata is actually going and accessing this specific object and comparing it to this search metadata schema that we defined up here. Then we use expect as well to basically just validate this validation. This is a Boolean object, so TV4 returns true or false based on whether or not these two things are the same, or not the same, but have the same form, are valid. So we use expect and expect that they should be true. Here, we ran this before, and we see a test result over here. So we do see that the two metadata schemas are aligned. Do we have any questions over this slightly more complex functionality? Obviously, there's a lot of powerful things we can do here, but this is just dipping our toes in the pond. Excellent. So let's move back to the postcon, or to the slide deck real quick. Here, we're just looking through what we've seen. So we went over that we are able to access status codes and the response bodies as text through the PM Sandbox API. All of this occurs in the testing tab of the request view. We can view the test results in the test results section of the response section. Here we also see that we looked at the search metadata schema and used TV4 to validate it. This is slightly more expanded functionality for the Postman Sandbox testing API. When we're summarizing, the tests are written in JavaScript and run after our response is received. We assert to look for status, headers, body, and time, and have access to all our requests and our variables. So in addition to that, we have a bunch of built-in libraries that we can use for things like JSON schema validation. I'll give you guys just a short minute here, and then we will move on to scripts. Please take the time to ask any questions that you might have. So we did have a question that was asking whether or not tests can be written in other languages like Python or just JavaScript. Tests can only be written in JavaScript within the Postman sandbox. If you were to use something like Newman, which is the Postman command line runner, you might be able to write tests that validate your responses in other ways, but that's something that would happen externally to the Postman app. Within the Postman app, you can only use JavaScript. Okay, so looks like we don't currently have any other questions. I'm just going to take 30 seconds and then we will continue on with script. Hi guys, welcome back. So we've had a question over what other libraries are available in the Postman sandbox by default, which we'll be covering in scripts actually. In addition to that, we've had a question over how the TV4.validate functions, whether or not we have to have a model that exactly matches, as in A to B, or the response is A, B, C. So if the response were to have an extra property, let's go ahead and look at what happens when we change the schema. Sorry. Right. There we go. Seems that my Postman has fled. Let's go ahead and grab that real quick. Awesome. So we are already expecting this. Let's see what happens when we delete this last little guy. So it seems that if we do have an extra thing within the schema, we can still have it valid. So we're no longer getting since ID string. However, if our key might be a little different, oh, looks like since we're still matching, that's a little strange actually. So the schemas do have the same form, but they should actually return differently. That is a good question, and that's something that we can definitely return to. If you want to tweet at me, we can get into it a little bit later. As for now, I would say that it's important to play around with the TV4 library on your own a little bit and experiment to see what's going on. So let's hop into scripts as part of our section. So scripts are globally within the Postman app, referring directly to what we're doing before and after a request. The tests we just went over are technically test scripts. Okay, thank you, Arnold. He's just clarified that you need a required tag in the schema to get a failure. So pre-request scripts are run before a request is sent and are really useful for doing setup that you need before you interact with your request. So basically, before you send your request, pre-requests allow you to change things in your environment, update variables, or maybe do some logic in order to set up. So the way that scripts actually function within requests is they are processed in this order. So before we send a request, we run a pre-request script. Then we send a request and get a response. And then we run our test script. So going back to the Postman sandbox, the entire sandbox is based on a Node.js JavaScript execution environment. Both of them are executed within the sandbox for tests and pre-requests. And this really enables us to do powerful dynamic things like we saw with the validation. So we had a question earlier about the different libraries that we are able to use within Postman Sandbox, and this is just an example of some of them. Like I said, I will be posting a reference to the Postman Sandbox API in the chat at the end of the meeting. Actually, we'll take a second right now, and just so you could look at it if you want, I'll go ahead and show you that. Here, let me see. So this is the Postman Sandbox API reference. Let's go ahead and post that in the chat. And it will allow you to explore all of the different libraries that you see here. Basically, each one it allows you to do different things, and they all point to their own different hosted websites that have their own documentation. These are all powerful included libraries that require some different setup for when you include them. We'll get to this a little bit later, but you do need to require most of these libraries before you can use them. So all of these libraries do different things. Sorry, looks like I've accidentally trapped my Zoom chat on my screen. Let's get rid of that real quick. Okay. All these libraries do different things, and we'll be looking at a few of them today. In addition to TV4, I believe that Moment will be coming up as well. So the Sandbox API gives us access to not just things like PM.test, but a variety of other things. So we saw PM.environment earlier, but we also looked at PM.global, and we can also define PM.variables. In addition, we'll be looking at PM.send request, PM.request, which allows us to access information in the request, similar to how we accessed information in the response, and PM.info, which gives us a general overview, an object that's a general overview of what's going on. So the test scripts only, we have access to the PM.test, PM.response, and PM.cookies. And when we're running collections, which will be our next webinar, we have PM.iteration data, and that allows us to interact with data files that we're in the middle of running. So within scripting, we have something called chaining. Basically, while using scripts and variable together, we can chain requests to build different scenarios. We'll be going over that a little bit later to see how, before we send a request, we can access information and change the request that we're going to send based on what's going on. We also might have an example of some sort of functionality where we want to get information and then update it before we access another request. These are both upcoming, and we will have examples of that. Another important concept is keeping things dry. So what we mean here is a lot of times you're going to want to be repeating code. And in the same way that we can define collection level variables, we can actually define collection level scripts. Beyond that, we can even define folder level scripts that in each of these exist on a higher level than request scripts. The way that scripting operates. So we see here earlier that we have a pre-request script and a test script that run before the request and after the response. But when you include pre-request collection and folder scripts, they run in this order. So first collection scripts will run, and then folder scripts will run, and then your request scripts will run. In the same order after you get your response, collection tests will run, and then folder tests will run, and then request tests will run. We'll show you this in just a second. So let's go ahead and pull out into the app and take a look at our Postman collection. So here we see our request script. What this is doing is it is actually utilizing a parameter within the Twitter API that allows us to define until. And this lets us see, basically it tells Twitter how far back we want to look. Here we're using one of those libraries that we looked at earlier, Moment. And you see when we want to use Moment, we have to require it. So we define Moment as a constant and require it within our sandbox. This essentially imports Moment and allows us to use its functionality. So we're setting 2 days ago equal to Moment. It's getting the current day and then subtracting 2 days from it and putting it in this format. So when you call Moment, it lets us know this current day and allows us to manipulate it. And then we're taking the environment and setting until to 2 days ago. So here we see that we do have until as a variable within our environment. PM.environment set allows us to change that. So we're going to go ahead and send our request. And it actually restricts things to since the past 2 days. We can change things to rather than PostCon 2018. Let's go ahead and just change it to PostCon. And now we see that some people have tweeted about PostCon in the last 2 days. So we have just a small return. But if we were to change this and edit our until to change it to, let's change this to 610 and update that. We actually see that the response changes. So that is an example of a pre-request script and how we can dynamically change what information we're sending before we send it. Another thing we can do before we actually send requests is we can change or we can send an extra request before we send our primary request. This is the PM.sendRequest function. In this case, we want to send a unique ID to Postman Echo. But in order to get that unique ID, we need to use an open API called Unique ID Generator to go and get a unique ID. So if we have an error, we'll actually be logging it to the console, and we'll see some of the, we'll be looking at the console a little bit later to see how we're reporting things. But if we don't, we will be setting this to the environment and using it to send to Postman Echo. So here we see that we did in fact send a unique ID. Let's go ahead and check on what happened within the console. Sorry. So you see here that we went and got, so we made this request to Postman Echo, and we also got this UUID from UUID Generator API version 4. So both requests were logged, and we actually have a few extra things that are popping up here. You may be wondering where these come from. So the collection pre-request script is actually, if we go ahead and look up here, right here. So if you had a certain piece of information that you wanted to display, for example, this would let us indicate where we separated different requests as we ran them. This is a good place to put them. In addition, we have this collection test script. So these run before every different collection that you run, or every different request that you run when you put them at this level. let's see, I don't believe we have any scripts defined here. But if we see here, we have defined some. So we will see when we run these that shows up within the folder. So PM.send request is another piece of powerful functionality that allows you to set information before you actually send your request. Let's look at script execution. So as we were talking about, we did see some of that in the console earlier. We're going to go ahead and run this request. We know that we have a pre-request script that lets you see this console logging and this text that appears in the test. Console.log is the recommended way to basically capture and record important testing information and put it to the console. So if you want to know what step you're at, whether you're in the pre-request or the test, a console.log is a good way to check in and see where your code is at while it operates. This will also give us a good piece of information on the order that things occur in within the console. Let's go ahead and send this request. So here we see that we have a collection pre-request script, a folder pre-request script, a request pre-request script. Then we actually have the request itself. And then we run our collection test script again, our folder 1 test script, and then our request test script. So we had a question of how to run the post API from a pre-request script of another API. So in the same way that you can send a request, you are able to post similarly to how you would send a GET request in this with the PM.send request piece or function. So if I've understood the question correctly, so the PM.value that has the name of the test collection or folder. To the best of my knowledge, there isn't a PM.value that does have the name of the test collection or folder, but I will do a little research, and if you tweet at me, we can go ahead and have a discussion about that. But this was actually a problem I was running into a little bit ago, that I wasn't able to access the name. So I believe it is something that isn't currently basically a variable that we can access via the Postman Sandbox API. Okay, awesome. So let's look at our second request. We have this second request that will pretty much do the same thing. So if we look in the console again, we now see that we run the same collection pre-request script, the same folder pre-request script, but because we're doing a different request, our request pre-request script is different. So it's important to remember that when you do operate on these levels, your collection and folder request scripts will remain the same no matter what, but your request scripts will change based on what you put in them. Let's go ahead and talk about chaining real quick. So we talked about this a little earlier on, and in this example, what we want to do is we want to get information from a weather forecast. Oh, yeah, and looks like Jason McKenzie has posted a hacky way to get the actual name of the request that doesn't use the PM basically prefix. So that is an interesting way to do it, and I think it should be functional. So let's go ahead and just show that on the screen real quick. Basically, that allows you to get the name of the request. So back to our chaining information. This is a collection or a folder within our collection that's going to allow us to get the current, basically the current information of weather for a certain location, and then go ahead and tweet it out. So this is our first request that basically looks at the response data for this API, the Open Weather API, that gets things for the city and the ID of the app that we're using. So let's go ahead and send that out. Oh, unfortunately, it looks like we have an invalid API key. So that's something that we'll have to screen, and you always need to check for that. So that shows us that are actually, this is a good case where our tests failed because we weren't able to work with the response body since it didn't exist, or at least the certain things that we were expecting. Let's go ahead and look at the console there. It's always good to look at the failures of what you're running and see what might have happened. So here we see that it was a type error right after our collection script that meant that temp min was undefined. Fortunately, we still have these things defined within our environment from the last time we ran them, so we can go ahead and proceed to our next script. In this case, you saw that we were dynamically setting the temp min and temp max in the environment, and now when we actually go to tweet, we will look at today's forecast and read those two things from the environment and go ahead and send them out. So looks like we've tweeted. If we go ahead and go to twitter.com, and we can look at that, and now we see that we've actually sent a request to Twitter and posted a forecast. So you can see that chaining, basically allowing you to set these two things together, will allow you to build more powerful functionality with scripts inside of your requests. This is a way to take tests and turn them into personas, build on top of them in order to go through more complicated workflows where you might be accessing multiple APIs, going and getting information and plugging them into different things. This is also a way to, if you, for example, in this case, want to accomplish functionality with Postman, like tweeting things out or sending things to Slack. Let's go ahead and pop back into our slides real quick. And I'll take a second to ask if anyone has any questions. Okay, looks like no one has any questions, so let's go ahead and move forward. Just covering what we've just reviewed. So we saw that we can use moment in our pre-request scripts to dynamically change variables in order to get different information from our request. In this case, we do need to require the different library that we are using and go ahead and use pm.environment.set to change our variable. Just an important reminder, this runs before the request always. So if you're trying to perform some sort of logic that prevents the request from running within your pre-request script, that is not impossible, but is something that is not really done. Oftentimes, we want to look at things when we're chaining and basically change that logic before we go ahead and run it. Next, we looked at send request as a way of sending requests before we actually send our central request in the pre-request script. So this is a good way of building, like we said, different pieces of functionality to get information first. It's an alternative to chaining and would basically be a more simple way of accomplishing this functionality. When you're building out more complex things, you oftentimes want to separate it into different requests that might require more dynamic interaction. Here we see our first example of chaining, where we went and got our weather data and then went ahead and tweeted it out. So that is a good example of a more complex situation in which we needed authentication and we needed to set variables. So that is a case where we probably wouldn't want to use that pm.send request, and instead we broke it out into two requests and changed them together to get that more complex functionality. We also looked at how to use the Postman console and console.log to look at what's going on within our requests and our scripts in the order in which collection, folder, and request scripts are run. So wrapping it all up, pre-request scripts are executed before, tests are executed after our request is sent. Our Postman sandbox is this JavaScript environment that we've been working in and pretty much allows us to manipulate things in this Node.js environment. We have a lot of built-in libraries such as Moment, TV4, Lodash, and Crypto.js that you are able to actually interact with, and we have the reference for you posted in the Slack, or not in the Slack, in the Zoom chat. And I will go ahead and post that up again, but it is good to just Google Postman Sandbox Reference API. So in addition, we can use the Postman console to debug our scripts and to look at our requests. And we can keep things dry by separating our scripts out to collection, folder, and request levels. Thank you guys very much for attending this Postman webinar. Next time, we'll be seeing how we can run collections, which takes our test and scripting to the next level. So if there are no further questions, I thank you guys very much for attending, and please keep in touch with our webinar page that we're posting in the Zoom chat. My Twitter is @ScottishKilt, and we're posting it in the Zoom chat here. Feel free to tweet at either me or the Postman client, and your questions will be answered. We also have a GitHub and a Discourse channel. Those things are both, we will post both of those in the Zoom chat, and we'll keep the meeting open for just a little bit so that we can get those to you. We encourage you, please reach out and ask us any questions or features that request any features that you might have. We're always open to listen, and we really love interacting with you as our community. So thank you guys very much for attending our webinar, and looking forward to seeing you next time.